We'll finish today's lecture by talking about thiols. Thiols are compounds which are also known as mercaptans. And thiols are really nothing else than analogs of alcohols in which an OH group has been replaced by an SH group. So this would be an example of a thiol, and this SH group is known as mercapto group. The reason why this is called mercapta comes from the mercury capturing properties of thiols, which are based on the fact that sulfur and mercury form very strong bonds, so complexes of thiols with mercury-containing compounds are very strong and are able to remove mercury from the environment. The same applies to some other heavy and toxic metals such as cadmium and arsenic, which also form strong bonds with sulfur, so thiols are used in environmental remediation of several of these classes of compounds. In terms of their nomenclature, thiols are typically named as alkane thiols. So this would be an example of an ethane thiol. This, for example, will be butane thiol. And this, I think, would be 2-butene 1-thiol. In terms of nomenclature, thiols are behind alcohols in the order of priority, so this compound would still be named as an alcohol, and this will be 3-mercapto propanol. And now we can also see that mercapto is the official name for the SH group. Probably the most immediately obvious characteristic of thiols is their offensive smell. Pretty much all sulfur-containing compounds have some sort of smell to them, but the smells of thiols are really, really nasty. And to illustrate this, these two compounds are components of skunk's scent, which is used as a defensive mechanism. On a more brighter note, garlic contains significant amounts of this compound, which might have some antibactericidal properties, but a lot of its garlic odor comes from this sulfur-containing compound. Just like alcohols, thiols are acidic, and they're actually more acidic than alcohol. So if we look at an equilibrium, thiol will be easily deprotonated by water, by hydroxide, to give us almost irreversibly thiolate anion and water. If you remember, for this reaction, for alcohols, we would get pretty much 1-to-1 equilibrium because the acidity of alcohols is comparable to that of water. The reason here is that the acidity of thiols is simply greater. It's 10.5 pKa versus pKa of water, which is 15.7. And they're more acidic simply because sulfur is significantly larger than oxygen, and even though it's less electronegative, it allows the negative charge in an anion to spread out over a large surface. And therefore, the thiols are stronger acids than alcohols are. Typically, thiols can be prepared by SN2 reaction. The hydrosulfide anion is an excellent nucleophile, and so this can readily react with acid chlorides to give us higher thiols. And in terms of their reactivity, they undergo similar reactions to some alcohols, but two things that are quite different is their ability to oxidize. Unlike OO bond, which is very weak and relatively difficult to get to, oxidation of thiols will give us, if it's mild oxidation, this can be typically done in air, will give us this compound known as a disulfide. And that's the interesting thing about it, is this oxidation is reversible. So if we treat this with reducing agents, we'll go back to disulfide. And this is a very significant reaction in nature because it occurs in proteins. And it occurs in proteins because proteins have one amino acid known as cysteine, which is a thiol. And cysteine as a thiol is able to engage into this disulfide bonding and that thus allows really cross-linking of polymer chains, which then changes their three-dimensional structure. And three-dimensional structure of proteins is hugely important in the way they function as enzymes or structural proteins. And so therefore this oxidation between, this equilibrium between thiols and disulfides has a huge physiological importance. But however, if we do exhaustive and irreversible oxidation, and this does not occur in the body, with compounds that we've seen already as strong oxidizing agents, such as potassium permanganate or simply nitric acid, we will get the thiol oxidized all the way to corresponding sulfonic acid. And you notice here the sulfur has 6 bonds around it, which is fine for sulfur since it's able to expand its octet to a large bond. So with this, we'll finish this really brief coverage of thiols as well as today's lecture. We've seen a couple of reactions that produce alcohols in novel ways as opposed to those that we've seen previously when we covered other classes of compounds. The most significant of them are the Grignard reaction and reduction of carbonyl compounds with hydrate-bearing reagents. Finally, in the last section of our lecture today, we covered a little bit of chemistry of thiols. Thank you.